Okay, so the first thing we started off with was NPVs. So we did a little bit of solving, but we'll go to that after. So that's whenever there's anything in the denominator, whether it's in the numerator, denominator. Like if the numerator has a fraction, you have to see non-permissible values. So we'll look at one first. So we're determining the NPVs for 3 sine x over cos x. And I want you to determine it in radians and degrees. Okay, so we have to state where cos x can't equal 0. So where does cos x equal 0? When x is, yeah, when x is 0. So when x is 0, it's pi over 2, 3 pi over 2, and keeps going. So x equals pi over 2 plus pi n NEI. In degrees, it's 90 degrees plus 180 n NEI. Number 2. Yep. Yep, good call. You are correct. It would make no sense if it could equal it.
So cos is the x and sine is the y.
Yes. Calgary Stampede, or cooking show, or
Calgary Stampede. Oh, okay. Calgary Stampede. Okay.
Alphabetical order, or all those stuff.
All right. I thought it was like so easy. I got this.
Cos x over tan x. That's number 2. Number 3. Sine x over 1 minus 2 cos x. So on the bottom, in the denominator, we have sine x over cos x. And then we have cos x, right? So we have to state where sine x can't equal 0 and where cos x can't equal 0. This is the easiest one because it's just every 90, right? Because you would technically start off with 0 plus pi over 2n NEI because it's every arm, but we don't write the 0. So it would actually just be can't equal pi over 2 n NEI. Or 90 degrees n NEI. Three, you did it with a sign. Yep.
Just a question about 2. Like if there was multiple choice, do they always give 2 separate general solutions, or are they always?
If they can put them together, they put them together. Write it as one. Yeah. So this one I gave you a sign, but let's pretend you can keep it the way you did it. But let's pretend instead of having a sign on the top, I had a cosecant. So what does that actually cause me to have? 1 over sine, correct? So I get 1 over sine x. Now, these are not, like, this didn't become that. Don't, like, go to your notes and be like, how did she get from a sine to cosine? You can't. I made up a whole different equation. Oh, no, it just warned me the battery's low. This is not going to make it the whole time. Okay.
I'll just film it, and then I'll just send it to you as a podcast.
No. So then, we have 1 over sine x divided by 1 minus 2 cos x. So we're going to have to state where sine x can't equal 0 and where 1 minus 2 cos x can't equal 0. So sine x can't equal 0 when y can't equal 0, which is at the 0, 180, 360, blah, 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 right? So you'd write 180 degrees can't equal 180 degrees n NEI, because we wouldn't write the 0, or pi n.
So that's if it's cosecant.
Yeah.
So if it's just sine, then we just do the 1.
If it was just sine, you just do the 1 minus 2 cos. Yeah. This wouldn't exist. So in your question, this wouldn't have existed. I just wanted to go over if there was a reciprocal identity, what would you do? So then negative 2 cos x can't equal negative 1. Cos x can't equal negative 1 over negative 2. So cos x can't equal positive a half. Where does cos x equal positive a half? At the 60s in quadrant 1 and quadrant 4, right? Can we write those together somehow? No. So it's going to happen at 60 and 300 because it's here and here. That's where the positive coses are. So what we're going to have to do is x can't equal 60 plus 360 degrees n NEI. Or x can't equal 300 plus 360 degrees n NEI. Or in radians, it would be pi over 3 plus 2 pi n NEI. Or 11 pi over 3, I think. 5 pi over 3? Oh, 11 pi over 6 is the other one. 5 pi over 3 plus 2 pi n. NEI. So it depends on which I ask you for, radians or degrees. Yeah.
Are you going to give us the unit circle thing again with that?
They fill in.
Yeah.
But remember on your diploma, it's not.
Does everyone, like, in the province fill out their own unit circles, or do they get taught like a different way?
What you can do is I've seen where there's charts and then you use cast rule and then you have to decide, okay, if it's in this quadrant and it's S, it's negative, and then it's 30, so you look at the 30 on the chart and you pick that, or they use special triangles. But then every single time you use either chart or special triangles, you have to use cast rule with it to figure out what sign you need to use. So I, instead of doing that, which makes people mess up because they forget the sign or something like that, I just say do your unit circle. It takes you a little bit longer, but ultimately in the end it saves you more time and much less chance of making an oopsie. But I can't say exactly what everyone else does. I think everyone here does unit circle. But I used to do chart and cast rule, but then they brought in the one unit they added into Trig was made hugely based on unit circle. So it's way better for you guys to just learn the unit circle.
We didn't use that?
It was the very first one where like they would give you point and ask you if it was on the unit circle. It would give you a value and ask you for the degree. It would give you the degree, ask you for the value. All that stuff. Okay. We'll skip ahead to, I'm just doing things that I think are ones that you might forget. So write each expression as a single trig ratio. A, sine 25 degrees, cos 65 degrees, plus cos 25, sine 65 degrees. A. B is cos pi over 6, cos pi over 12, minus sine pi over 6, sine pi over 12. What should you spot here?
So the equation.
The sum and difference equation thing. Yep. And the way you spot it is this has a 25, this has a 25, this has a 65, this has a 65. This is a pi over 6. This is a pi over 6. Pi over 12. Pi over 12. If they were all different, you couldn't use that formula, right? Now, this one has a plus sign. And it goes sine, cos, cosine. Which one goes sine, cos, cosine? What if it was sine, cos, sine, cos?
Same thing.
It would be the same thing, right? As long as this angle correlated properly. Because this is A, B, B. So that one follows the addition of sine. So you just go sine 25 degrees plus 65 degrees, which equals sine of, and then you could even give it an answer, but it didn't ask for an answer, it just said a single trig ratio. And then here we have A, B, B. So this is cos addition. So it's going to be cos pi over 6 plus pi over 12. Do we want to do the actual math properly? It's going to be 2 pi over 12 plus pi over 12, which is 3 pi over 12, which is pi over 4. Okay, I'm going to go over 2 other questions that everyone forgets about. I want to see if you can do them without me telling you how to do them. 3. Believe in yourself. I bet you will. If cos theta equals 3 over 5, and that's a 5, even though it doesn't look like it, and 0 is less than theta, is less than 2 pi, determine the value or values of sine theta plus pi over 6. That's number 3. I'll come back. And then number 4. Blur stuff.